This screencast is meant to be an introduction to the language that we'll be using when we're talking about forces in our Unit 4 of Physics. I'd like to begin by asking you to copy down this chart in your notes so that we can fill it out together to make sure that we have a sense of what we're going to be talking about when we try to discuss and analyze forces acting on objects. In order for us to really have a sense of what forces are, we need to come to a common definition of what a force is. There are many ways you can define a force. In physics, I think that there are probably two ways that would be good to think about a force. The first thing would be that a force is actually just a push or a pull. This is a pretty basic understanding of what a force is, and it works to get us started. I'd like to extend that thinking a little bit by asking you to consider it that whenever you push on something or whenever you pull on something, you are acting with that something. There's actually an interaction that's happening. And so I'd like you to think about a force as also being an interaction between objects. And this interaction between objects is going to become really important for us in our analysis of what forces are. Now, there are several common types of forces that we'll be discussing in this course, and so I wanted to kind of identify what those were and to kind of talk about the direction that they act, when we should really be considering its being present, and a symbol to actually use for that force. We'll fill in the equation piece later on once we do a little bit of work in analyzing forces. So sometimes when we talk about a force that's acting on an object, people often talk about gravity. That's a pretty common force. So the first one we're going to talk about for type is the gravitational force. And the gravitational force is actually going to be pointing towards the center of the more massive object. So in our case, it's going to be pointing to the center of the Earth. And we're going to have it whenever we're near a planet. So if there's a planet nearby, we're going to be experiencing that gravitational force. The symbol for this is just going to be F for force, and we're going to use a subscript of a lowercase g to show that it is a gravitational force. Now, another type of force that can actually be present is a normal force. This is a different kind of word for what we're talking about, but it's any force that acts perpendicular to a surface. So if I push on a chair, I'm going to be probably pushing perpendicular to the handle or the back of the chair. If I'm sitting on the chair, the direction of my sitting is perpendicular to the seat of the chair. What's interesting is anytime these surfaces are in contact, pushing against one another, atoms are actually getting squished or crunched. That's actually when this force is present. So anytime you push on a table, anytime you push on, even if you kick a soccer ball, we are actually crunching atoms. You'll see a demonstration about this next week. The symbol for this is a capital F and a capital N subscript. Sometimes we might actually rub surfaces against one another. If I want to slide the hover puck across the ground and I don't have it turned on, we'll experience a frictional force. And this frictional force always acts parallel to the surfaces. We could say along the surfaces that are involved in the interaction. And we're also going to get atoms that are kind of scraping against each other. You could also talk about the atoms are being sheared or rubbed against one another. And sometimes, in the process of that, others will actually be crunched as well. I know that that's pretty technical terms. And the symbol for a frictional force, we've got to use actually a lowercase f because of the fact the uppercase F is being used for forces. As winter approaches, we actually have the opportunity to experience another force. When I think about pulling my child on a sled, I have to use a rope to pull him, that would actually be considered a tension force. And the tension force always acts in the direction of the string. So along the rope, that would be the direction. And this could be a rope, a string, a cable, a cord, whatever is happening. But whenever that's happening and the rope is taut, if it's nice and tight, then we're going to have that tension force. Interesting thing about strings and ropes and cords and chains, they never can work with pushing. They only ever work with pulling. And that's why the rope being taut or the string being taut is a very important thing. Symbol for this, F with a subscript capital T. The last one we're going to introduce today is a spring force. We see springs acting on things when we go to the grocery store. There's a spring scale. We've used spring scales. Just like along the rope for the tension force, the spring force acts along the direction of the spring. And the spring's always kind of trying to restore it to its unstretched or uncompressed length. So that's something that's interesting to think about. It's present whenever the spring is stretched or compressed. And the symbol that we'll use for force of the spring is F with a capital S for the subscript. So in our chart, we have these different types of forces: gravitational, normal, frictional, tension, and spring, and the symbols as we see them there. What's interesting to think about when we think about an interaction between two objects, sometimes these objects touch one another, and sometimes they don't make contact with one another. That's where we will begin our lesson when we return next week.